This video, we're going to prove the following fact. Phi of any number is greater than or equal to 1/2 times the square root of that number. And we're going to use two facts that are going to help us. The fact that p minus 1 is greater than the square root of p. Think p has to be at least 3 for that to be true. So we'll see. Okay. So we're not going to have p equals 2. And another fact we're going to use is that k minus or half is always bigger than k over 2. If k is a half, if k is bigger than 1. If k is bigger than 1, this is true. In fact, if k equals 1, we have equality. After all, 1 minus a half, which is a half, is equal to, k is 2, 1 over 2. So we have equality when k is 1. But as long as k is 1, at least 1, k minus a half is bigger than k over 2. So, proof. If you like watching mathematical proofs like for the fact in front of you, subscribe to my channel, as this is all we do here. Okay, so how about we let n equal 2 to the k sub 0 times p1 to the k1, p2 to the k2, all the way up to pr to the kr. Okay. Well, since all of these are pairwise relatively prime, phi of n is going to equal to 2 to the k sub 0 minus 1 times 2 minus 1, which is 1, p1 to the k1 minus 1 times p1 minus 1. Actually, I'm going to put the p1 minus 1s on the end. So we have p2 to the k2 minus 1 all the way up to pr to the kr minus 1 times p1 minus 1, p2 minus 1, all the way up to p sub r minus 1. But I'm going to put something on the next line greater than those. So it's going to be greater than 2 to the k sub 0 minus 1. Ignore that. It is 1. Times all of this. p1 to the k1 minus 1. p2 to the k2 minus 1. All the way up to pr to the kr minus 1 times, I'm going to put something actually smaller, the square root of p1, the square root of p2, all the way up to the square root of pr. But you know what? I'm going to write the powers 1/2 instead of using the radical sign. Now, this is equal to 2 to the k sub 0 minus 1 times p1 to the k1 minus a half, because we have k1 minus 1 plus a half. We have k sub 2 minus 1 plus a half. P sub 2 raised to the k2 minus a half. All the way up to this times that being pr to the kr minus a half. Okay, now since these primes are bigger than 1, all primes are bigger than 1, if you raise them to bigger powers, you get bigger numbers. If you raise them to smaller powers, you get smaller powers. That's 2 to the k sub 0 minus 1, and I'm going to make the powers smaller. I'm going to use p1 to the k1 over 2, p2 to to the k2 over 2, all the way up to pr to the kr over 2, starting to look like the square root of n, but not quite. Now, I'm going to write equals. I'm going to divide the bottom by 2. Divide the bottom by 2. So I still have p1 to the k1 over 2, all the way up to pr to the kr over 2. But if I divide the bottom by 2, I have to multiply the top by 2. So that's just going to be 2 to the k sub 0. But that's bigger than 2 to the k sub 0 over 2. And everything else is going to stay the same. PR to the KR over 2. All over 2. Well, here's the over 2. That numerator is simply the square root of n. Okay, if n is equal to 3 to the 6, 5 to the 8, 7 to the 12, then the square root of n would be the square root of this, which is 3 cubed, times the square root of that, times the square root of that. The powers are just half. And that's exactly what we have. The powers are half of what they used to be. So we get the square root of n over 2, and the proof is completed right there. You don't need this. Hopefully it was helpful, but it's not part of the proof. And I showed that this here, phi of n, is greater than or equal to the square root of n over 2. Phi of n is equal to this, which is greater than or equal to that, which is equal to that, which is greater than that, which is equal to that, which is greater than this, which equals that. Phi of n is greater than the square root of n over 2. If you like watching videos like this, seriously consider subscribing to my channel. Please leave a comment. I'll see you folks in the next video. Click the like button. Watch and learn. Have a good one.